All right, in section 110, we're going to talk about modeling variation and the different types of variation that we have out there. First one that we're going to talk about is direct variation. Direct variation is when you hear the words varies directly, directly proportional, anything like that, where you hear the words directly, you're going to see this type of format. The K in this particular thing refers to constant. Okay, and that's a number that we're going to find. It's also known as the constant of proportionality. But you'll hear the words constant, or you'll hear the words direct in here to know that it's this type of situation. Inverse variation is where you have y equals k divided by x. And again, constant is still that k. And again, you'll hear words like inversely proportional or varies inversely or something like that along those lines. So jumping into the problems, just so that you guys know, this is what you would have to be seeing. If it says A varies inversely, as R. So as soon as you see this word inversely, we're going to say A, and then it's going to be K divided by R, because it's an inverse type situation. Then beyond that, it'll say if R is 3, then A is 7. And what they want you to do is they want you to find the constant. So when you're doing this, you put 7 in for A, you don't know the constant, you put 3 in for R, and now you solve for K. And how do you get rid of divide is you multiply both sides by 3, so I get K equals 21. And then they want you to rewrite the equation, so it'll be Y equals 21, or not Y equals, sorry, different letter, A equals 21 over R. And then that way you can solve it for any specific one you want. Okay, so that's an example of inversely. Directly, it says P is directly proportional to T. Okay, so again, it's P equals KT in this situation because we have varies or directly proportional, so we're going to use that directly, the directly equation there. So again, it's going to give you if T is 300, then P is 20. So you're trying to figure out what K is. So if I got 20 in for P, I don't know K. I put 300 in for T, and then I divide by 300. And when I reduce that fraction, I end up with 1 over 15. As a decimal, I'm not really sure what it is off the top of my head without a calculator in front of me, but I usually prefer it as a fraction anyway. So then there's me rewriting it as a problem. So just so that you guys know, that's how you come up with the constant. Is it's going to give you a couple different pieces. You have to then work backwards to find it. Then from there, they're going to give you problems that will deal with this. Also, before I forget, if you see the words jointly proportional, that just means that you have more than one thing going on. So if it says if it's jointly proportional to this, then that just means you have 2 or more things happening. So just so that you know, that's what's going to happen for that. In a word type problem, it says something like this. It'll say power from a windmill. The power P that can be obtained from a windmill is directly proportional to the cube of the wind speed. So when you're doing that, you hear the words directly proportional. So that means we're going to go P equals K is in the top, or in the, and then it's going to be a multiply situation. But it says cube of the wind speed. So that means we're going to cube that wind speed like that. So as far as expressing or writing the equation, we've done that. Now it says find the constant when the windmill produces 96 watts of power when the wind is blowing 20 miles per hour. So 96 K 20 miles an hour cubed. Then once I get that, actually I have to take out my calculator here for a second. I'd have 96 divided by 8,000 K. And when I get that number, I get 0.012. That's my constant. Okay. So now, as far as having a formula right now, I have P equals 0.012 S cubed. And then it'll say how much power is the windmill going to produce if the wind increases to 30 miles an hour. So there's where I just leave that as my constant, but now 30 is going to go in for there. And I type all this in as it looks, and I get 324. And in this case, we're dealing with watts. Okay, so just so that you guys know, that's section 10. It's a pretty short section as far as how to come up with those problems. So, all right, thank you.